In this lesson, we're going to learn how to multiply with decimals. I'm going to start with this first example, and I'm going to multiply just like I would with whole numbers. And I see that 2 3/10 has 2 digits and 7 only has 1, and my personal preference is to put the longer number on top of the problem. I am not going to worry about lining up my decimal when I'm multiplying like I do when I'm adding and subtracting. So I'm going to completely ignore my decimal and I'm going to multiply just like normal. So 7 times 3 is 21. Carry my 2. 7 times 2 is 14, and 14 plus 2 is 16. So if this were just 7 times 23, I would have 161. But now I need to pay attention to the decimal. So I am one place behind the decimal. And if I am one place behind it in the problem, then I will have one number behind it in my answer. So 2 3/10 times 7 equals 16 and 1/10. And this makes sense because this number is a little bigger than 2. So 2 times 7 is 14. So a number a little bigger than 2 times 7 would be a little larger than 14. Let's try our next example. Once again, the first number has 3 digits, so I'm going to put it on the top of my problem. And it just so happens in this problem that the decimals are lined up, but I don't have to line them up. So now I'm going to completely ignore the decimals until the very end, and I'm going to pretend this is 36 times 104. So I'm going to start with 6 times 4 is 24. 6 times 0 is 0, and 0 plus 2 is 2, and 6 times 1 is 6. Down a row, add a 0. 3 times 4 is 12, carry the 1. 3 times 0 is 0, plus 1 is 1, and 3 times 1 is 3. Now I'm going to add. 4 plus 0 is 4, 2 plus 2 is 4, and 6 plus 1 is 7, and 3 plus nothing is 3. So now that I have come to the very end of my problem, I'm going to go back to the very top and look at how many numbers are behind the decimal. So there is one place behind the decimal in the top number, and there is one place behind the decimal in the second number. So I'm going to add these two numbers together, and that will tell me that I need 2 numbers behind the decimal in my answer. So 10 4/10 times 3 6/10 equals 37 44 hundredths. And once again, I can use rounding to help me make sure that my answer is reasonable. So 10 4/10 is close to 10, and 3 6/10 is close to 4, and 10 times 4 is about 40. And because this is smaller than 4, it makes sense that my answer is a little bit smaller than 40. So when you think about multiplying with decimals, I want you to think multiplying is when you move it. You're going to count how many numbers fall behind the decimal in the entire problem, and you're going to move it that many places in your answer. Let's try a few more examples. I'm going to start with 24 and 53 hundredths, and I'm going to leave it at the top of the problem since it has the most digits, and then 9 and 1/10. Now that I've set up my problem, I'm going to ignore my decimals. 1 times 3 is 3. 1 times 5 is 5. 1 times 4 is 4. 1 times 2 is 2. Go down a row and add a 0. 9 times 3 is 27. 9 times 5 is 45, and 45 plus 2 is 47. 9 times 4 is 36, and 36 plus 4 is 40. 9 times 2 is 18, and 18 plus 4 is 22. I'm just going to put the 20 in front of the 2. Now I'm going to add up. 3 and 0 is 3. 5 plus 7 is 12. 1 plus 4 is 5, and 5 plus 7 is 12. 1 plus 2 is 3. And then I'm going to bring down both of my 2's. So now I'm going to go back to the problem, and looking at the top number first, there are 2 numbers behind it in the decimal. And on my second number, I have 1 number behind the decimal. So there are a total of 3 place values behind the decimal. So I'm going to make sure that there are 3 numbers behind it in my answer. So 24 and 53 hundredths times 9 and 1/10 is equal to 223 and 223 thousandths. Now, to check and see if this is a reasonable answer, I can use rounding. So 24 and 5/10 is close to 25, and 9 and 1/10 is close to 9. I know 9 times 5 is 45. 9 times 2 is 18. And 18 plus 4 is 22. So my answer should be close to 225, which 223 is. So I know my answer is reasonable. Now let's try one more example. 20 and 7/10 times 3 and 85 hundredths. And because there are 3 digits in both of these numbers, it doesn't really matter which one goes on top. So I'm going to completely ignore my decimals, and I'm going to start with 5 times 7. 5 times 7 is 35. 5 times 0 is 0, plus 3 is 3. And 5 times 2 is 10. Go down a row and add a 0. 8 times 7 is 56. 8 times 0 is 0, and 0 plus 5 is 5. And 8 times 2 is 16. Now I'm going to go down another row and add 2 zeros. 3 times 7 is 21. 3 times 0 is 0, plus 2 is 2. And 3 times 2 is 6. Now add, this is going to be 5, 3 plus 6 is 9, 5 plus 1 is 6, 1 plus 6 is 7, and 7 plus 2 is 9, and 1 plus 6 is 7. Now I'm going to go back to the problem. There is 1 number behind the decimal in the top number, and there are 2 numbers behind the decimal in the second number. So there are a total of 3 numbers behind the decimal. And if there are 3 behind it in the problem, there will be 3 behind it in my answer. So 20 and 7/10 times 3 and 85 hundredths is equal to 79 and 695 thousandths. And to check myself, I'm going to round. 20 and 7/10 is close to being 21. 3 and 85 hundredths is closer to being 4. 4 times 1 is 4. 4 times 2 is 8. My answer should be close to 84. And 79 is reasonable because both of these numbers were lower than the numbers that I rounded them to. Using rounding to help estimate your answer can help you guarantee whether or not your answer is reasonable. Now try these 4 problems. Remember, you want to count how many numbers fall behind the decimal in each problem, and the total is how many will be behind the decimal in your answer. Also, use rounding to check and see if your answer is a reasonable answer.